All right, so this is just a really awesome little demo to help you kind of build an idea of how sine waves work and how cosine waves work, and we'll even introduce tangent ones here in just a moment and see how they're really cool, but they're totally different than the other two. There are two pictures on your screen at the moment. The one on the left should look like the unit circle because it is. So it is a circle with a radius of 1 unit in all directions. So it has all of those same parts that you're used to. And then the graph on the right-hand side is a trig graph. So the x coordinates are your angles. You can see the little theta there. And what your y coordinates are is your y coordinates are the height at each angle that we rotate through. So just like we just did in developing the sine and cosine waves, this is just going to do a really cool job of just sort of painting it as it goes. So it kind of shows you it's like a wheel turning over here on the left-hand side, and how high up off the ground or below the ground you are at each rotation that you end up making. And I tried to line it up so that you notice that a height of 1 over here is straight across from a height of 1 over here, so that they're going to kind of paint together. And I have it set to start at an angle of 0, so when this thing starts drawing, it's going to start drawing all of the sines, which again are all the y coordinates on this circle for every rotation. So it's going to start drawing all of the sines for each angle. You'll notice the angles on here are labeled in degrees. The ones we just did were labeled in radians. It shouldn't matter. It doesn't matter at all, and it's good that you actually get used to seeing them in the two different forms. So like on our graph, 360 was 2 pi, so this should look the same as our graph did at 2 pi. Same as our graph did at 1 pi for 180. Same as our graph did at pi over 2 for 90, and so on. And I set the picture up so that it runs from negative 2 pi up to positive 2 pi. So I'll start it in just a second here if I can find the play button. Okay, so playing from 0 degrees. The curve starts drawing. Oops, stopped it just a little short. Okay, until it gets to 90. So this just rotated 90 degrees. It just rotated from here up, and you can see the thing drawing. So at 0 degrees, here's the sine. Sine goes up really quickly to start. Okay, and you can see that over here. The height's going up really quickly to start. But it's just like throwing a ball up in the air. Okay, it starts out going up really high, and as kind of gravity pulls down on it, the height kind of slows down until it reaches 1. So notice the height kind of slows down until it reaches 1. And that's where like the calculus piece of it comes in, and why like trig values and sine, cosine, tangent stuff is really big with calc. It's because it's kind of modeling motion and what happens and the rate at which things are speeding up and slowing down. Okay, so if I play it again, now I'm going to try to go from about 90 to 180, which if we look on the unit circle, we're at 1 now at 90 degrees. If we finish rotating, when we get to 180, the sine should be back to 0, like if you look at your own unit circle. Okay, so I'll play another 90 degrees, and it paints it dropping down all the way till it hits 0. Okay, and now as it's rotating through, it's now reaching negative numbers. Okay, it's heading towards negative 1, and so our graph is at 0, and it's going to head towards negative 1. Okay, so if I do the next 90 degrees, okay, as we close in on that 270 over here on the left, okay, we're closing in on negative 1 for the sine value. Okay, so we can see it's just straight across modeling the height. And then as we finish off the full circle, we get back to where we started. Okay, so this thing has rotated through one full circle, just crossed 0 and is back into positive numbers. Okay, and this one over here has just crossed 0 and it's back into positive numbers. Okay, and so it's painted that same sine curve that we just looked at and just kind of built from scratch. Okay, so now I'm going to let it run for a while and just sort of see what happens. So try to look back and forth between the picture on the left and the picture on the right. It's going to go really fast, so you're not going to totally be able to keep it straight, but just sort of notice that kind of pendulum-like motion that it's doing, okay, which is exactly what a sine wave is. Like the sound waves that you're hearing as my voice right now are those same sine waves. Okay, so I'll just let it run. Peaks at 1, drops down, hits negative 1, comes back up. Okay, and then it starts back over on the negative side, hits 0, goes down to negative 1, hits 0, goes back up to positive 1. Okay, and just keeps that cycle going over and over. Hits 0, paints it back up. Okay, and sine will continue to roll and continue to roll. Okay, and so again, pretty cool pattern that we see there. Okay, so I'm going to get rid of sine here for a second, see if it'll do it for me. No, so let me hit reset. Okay. So I'll pause it. Okay, now I'm going to drag the angle back to 0, and we'll look at what cosine looks like. So we'll paint cosine this time. Notice it's already starting it at 1 because cosine are the x values. Okay, and right when we start drawing an angle, the x value is 1, okay, because the x values go this way. So as it starts to rotate, that x value is going to drop, okay, because the x value keeps getting less and less and less as we work our way around until it gets to 0, less and less and less until the x value gets to -1, and then it starts coming back. So it's like a pendulum swinging back and forth between +1 and -1. Okay, and it's going to go faster in the middle, and it's going to slow down as it reaches the edge. Again, just like a ball bouncing up and down. Okay, so we'll just watch this one go through its cycle as well. Okay, and so there's what we drew for the first piece of cosine. Starts at +1. Once it makes that full circle, once it gets to 360, it ends at +1. Okay, and it's going to repeat as well, because once you make a full circle, all your numbers repeat. We get those coterminal angles. Those ones that end up in the same spot, they're going to have the same trig values, which is why these sine and cosine graphs are so neat. Is that they just repeat and they cycle and they cycle and they cycle. Okay, notice it dropped back in at the -2 pi and repeats, but actually in all reality it just keeps going for forever. So as many coterminals or as many rotations as you want to make, you can make, and it should continue to follow that cycle. Okay. So that one again, it's pretty cool just to see how it pairs up, and even when you look at the at the unit circle that's rotating over here on the left, you can see it drawing the triangle. You can see that red is the x value, how far away from the y-axis you are. So I'm going to freeze it here once it gets back to about 0. Ooh, pretty close. Okay. And now I'm going to draw them both side by side. So I'm going to let them both run at the same time. And you can kind of see how they interact with each other. Okay, so both sine and cosine are being sketched right now. Okay, so you can see like over here as sine hits 0, cosine hits 1. Same thing over here. When sine is 0, cosine is 1. And so you see kind of these repeating patterns. And let's just give it a minute to get back to 0. And so if you look at it, and you look at a cosine wave, which are the red ones, and look at a sine wave, which are the blue ones, what you'll notice is they're the exact same thing. Okay, as you rotate through the unit circle, you're going to hit the exact same trig values in the exact same order. They just start at different spots. Okay, when you're at 0 degrees, cosine is 1. Okay, that's why cosine starts at 1. Okay, when you're at 0 degrees, sine is 0. That's why sine starts at 0. Okay, so it's like sine is sort of chasing cosine this whole time. So the cosine's already been there, sine is going there, but they're hitting the same spots in the same order, which again is really, really cool when you eventually start to understand what's going on in the background behind it. And it shows that we could like slide them over, we could do little shifts, left, right stuff to get them to completely match up. Okay, because again, cosine is just, depending on how you look at it, 90 degrees behind or 90 degrees ahead of sine at all times. So they're 90 degrees apart right here, the difference between the two of them. Okay? Because when cosine is 1 over here at 0 degrees, sine is 1 at 90 degrees. So there's a 90-degree difference between sine and cosine at all times. Okay? And so as you let it go through, you will see those two exact same paths being taken just at different points in time, which is really, really neat. So again, those are the sine and cosine ones you just looked at. For a quick demo, just because we're here, I also want to show you the tangent one, just because it's a lot of fun. Because the tangent one is going to look totally different, because we know from doing unit circle stuff way back in chapter 13, it kind of sucks that these things aren't side by side like they would have been, where this would be a fresher. But tangent eventually goes undefined. Because eventually we get to a point where the tangent, the bottom of the fraction is 0, and we can't have that. So tangent is not going to be a smooth wave like sine and cosine. Tangent is going to be broken up into chunks. Okay, so let's see actually if I can get this to clear out completely and get this blue one off of here. So let me pause, drag this over. So hopefully it deletes it. Please, maybe? No, okay. That's lame. Okay, so we're just going to ignore the blue one. That's just going to sit there because I don't know how to get rid of it right now. Okay, so starting at 0 degrees, tangent is broken up into pieces. Okay, so we see tangent's more like a lightning bolt going through. Okay, and I'll let it paint all of them all the way across before I kind of talk about what's going on there. But you notice the sort of lightning bolt shape that it takes going through, and then it starts a new one. Okay, and then going through, and it starts a new one. Okay, so finish one more, right about there. Okay, so tangent separate. Okay, within this span of 2 pi on both sides, we got 1, 2, 3, 4, 5, 6, 7 full lightning bolts, and then a half over here and a half over here. Okay, and you'll notice at every 90 degrees, it's split. Okay, and if you look on your unit circle, if you go back, you look at 90 degrees, the tangent at 90 degrees is undefined. Okay, so there are vertical asymptotes here at each 90 degrees, separating them from each other because they're undefined there. Okay, and then right after that 90 degrees, tangent is the most negative thing you could ever imagine. Rises at 180 degrees, tangent, so over here at 180 degrees, tangent is 0. And then it rises to the biggest number you could ever imagine, and then hits an asymptote at 270, which again is 90 degrees away from the ground. So it's all about reference angles, which is why we studied those in the first place. So every place where it's broken is every place where there is a reference angle of 90 degrees, because that's all the spots that are 90 degrees away, which are all the spots where tangent is undefined. Okay, and so if I let tangent run, it's just going to continue to make those bolts through and through and through, which is, again, pretty neat once you start to kind of grasp where all the pieces come from. So just a cool demo. Got kind of long because I got a little too excited about it, but hopefully you can just sort of see where the things are coming from. You don't have to totally understand it because that's like a calculus thing. That's not even a pre-calc thing. But if you can just sort of see what things look like and how they're put together, that's pretty neat. So yeah.